These are the 1.1a notes for PreCalc. Today we're going to be talking about functions. So first, what is a function? Here's your definition. It's a special type of relation that for each input there is exactly one output. So what does that mean? A relation is just a pairing of numbers. And a function is where for each x input, there is only one y. An easy way to think about it, the x's can't cheat. And what I mean by cheating, if you think about a relationship, cheating is when you're supposed to be with one person and then you're with somebody else. So once the x is paired with a number, it has to remain paired with that same number. It can't pair up with a different number. So for each of these, we're just going to say yes or no. Let's look at the first one. 2 is paired up with 1. And then you can see 8 is paired up with 3. And then 8 is paired up with a different number, 5. That is not a function. Once 8 is paired with 3, it has to remain paired with 3. And as soon as it pairs with a different number, it's not a function. Example 2, 1 is paired with 6, 2 is paired with 5, 3 is paired with 7. Everything looks good there. That's a yes. For example 3, as I scan through these numbers, I notice -3 here is with 11. And then I notice -3 is paired with a different number, 8. When that happens, that's a no. The x is cheating. It's repeating with a different y value. Number 4 is a yes. None of the x's are repeating with different y's. None of the x's are cheating. And number 5 is a yes. We don't mind if the y's repeat. So the y's can be cheating, but not the x's. Take a moment and try 6 through 10. See if you can decide which of these is a yes and which is a no. All right. Number 6 is a no. And the reason is this 8 right there is paired up with 2 different numbers. 7 is a yes. 8 again is a no. -1 is paired up with 2 different numbers. Number 9 is a yes. The y's are allowed to repeat. Number 10 is a no. That's because of that 3 repeating with the 2 and then again with the 8. All right. Now on a graph, we can't easily see the numbers. So what we're going to do is something called a vertical line test. Vertical line test. Vertical is an up and down line. And what you're going to do is you're just going to draw a vertical line through the graph, or you can even take your pencil and roll it over the graph. And if you do that anywhere on the graph, you'll notice that this one, the blue line, is touching the graph once and twice. That means that x value is paired up with 2 different y values. You have a point at the top and the point at the bottom. So when that happens, it's a no. If you look at problem 12, if I drew a vertical line, it only touches the graph once. If I draw it somewhere else, still only touching once. If I draw it somewhere else, still only touching once. So as long as it only touches once, it's a yes. What do you think about 13? Take a vertical line, draw that, see if it crosses more than once. All right, so when I draw my vertical line over here, it passes the vertical line test. But as soon as I draw it over here, notice that is crossing 3 times, which means that x value has 3 different y values paired with it. So that's a no. All right, now evaluating functions. So functions are just equations. In algebra, we used to write them as y equals. Y is the same as f of x. So now we're writing in a new notation, and this is going to be helpful the further you move on through math, so we're practicing it now. So this equation, f of x equals 3x plus 5, that's just like saying y equals 3x plus 5. And right here on part A, When they put a 6 in for the x, they're asking us to plug 6 in for the x. Plug 6 in for the x. They've already done it right there, so I don't need to do anything in front of the equal sign. My job is to work after the equal sign and plug in the 6 where I see the x. Multiply, add, and there we go. Same thing happens on part B. They're asking us to plug in a 7x where the x was. So 3, I'm plugging in the 7x. Finish it off with a plus 5. Multiply it out. I don't have any like terms to combine, so that problem's done. For part C, notice the 4 is in front, not inside the parentheses. So they're asking us to put 4 in front of our equation. So our equation is 3x plus 5, and if I need to put a 4 in front, I got to put this in a parenthesis to put the 4 in front there. And from there, I'll multiply. For part D, it's asking me to do two things. It's asking me to put a negative in front, and it's asking me to plug in x plus 2. So I always like to save the negative till the end. I'm going to do that last. I'm going to plug in the x plus 2 into the equation. Notice that I'm not doing anything with a negative out in front. We'll distribute. Combine like terms. And then at the very end, we'll take this negative and bring it down in front as a -1. And then you can distribute. All right, example 15 on the backside is more of the same type of problem. It's just that you have a new function now. So our function now, it's a little bit more complex. 2x squared minus 4x minus 3. So part A, f of 3, it's asking us to plug a 3 in for the x. And we're going to plug it in twice, one for that x and once for that x. It's important that we always do our exponents first. So this part has to be done first. 3 squared is 9. Then we can multiply. And then you just subtract all the way through at the end, giving you 3. We'll write a little note. Do exponents first. All right, part B, asking us to plug in a -5x for our x's. Looks something like that. And then as we do this part right here, oftentimes I find it helpful to kind of bring that to the side. So -5x squared, it's the same as writing it twice and then multiplying. Sometimes that helps make things a little bit more clear with the exponents, especially if you have negatives, numbers, and the x's. So I multiply a negative times a negative to get a positive, 5 times 5 to get 25, and x times x to get x squared. Then I can just bring that over into my equation, 25x squared. We'll bring everything else down. Or if you want in that step, you could multiply those. And then we'll multiply. And minus 3. And there's our final answer for that. No like terms at the end there. All right, for part C, we're going to plug in an x plus 1 into our equation for the x's. So 2 times x plus 1 squared minus 4 times x plus 1 minus the 3. I'm going to work this little piece here. Same way I did up here. This one's going to be different. I have to FOIL this. So x plus 1 squared. We're going to write it out twice. And then we'll FOIL. If you don't like the idea of FOILing, you can always double distribute. So take x and multiply it once and twice. And then take the 1 and multiply it once and twice. It's essentially what FOILing is. So x times x, x squared. X times 1, 1x. 1 times x, 1x. 1 times 1 is 1. And we'll combine our like terms to get x squared plus 2x plus 1. And then we'll put that into our equation here, x squared plus 2x plus 1. Bring everything else down. And then you could distribute. When you distribute that 4, make sure you distribute it as a negative 4. Right, so that's where we're at after we multiply. And then let's combine like terms. If you know how to do that, go ahead and try. And we'll go through it in just a moment. The 2x squared is the only x squared in the problem, so we'll bring that down. We'll combine the 4x and the negative 4x. Those actually cancel out completely, so I don't have to write the x at all. And then I'm going to add my numbers together. So 2, negative 4, and negative 3 makes negative 5. So my final answer, 2x squared minus 5. And on the last ones, we've got these graphs, which are actually the easiest part of the whole thing. We're going to look at our first graph here. And when it asks you for f of 1, they're saying x is 1. And they want to know the y value that goes along with it. So if x is 1, right here, y value would be 3. Then the next one, f of negative 2. Here's negative 2 as the x. That's our answer for the y. F of 2 must be 5. All right, and then they give us a different graph. This one they called H. And this one does not have our numbers labeled on it, our points labeled, but that's okay. We can go to H of 6. So here's 6. You can go up to where the graph is. It looks like that point is right there. And then you can look over to the left side and you can see that it is at 8. So if they had named that point, it would be 6, 8, which means H of 6 equals 8. If that's the x, They want to know the y. All right, so we got the 6. Next is the 0. 0 would be right here. You can see up at the graph, it's all the way up to 3. And for the last one, -4. And the y value, 0.